Hello, this is Jaeyong Shin from Seoul National University. From now on, I'm going to start my presentation with the subject of Stereoscopic low-latency vision system via Ethernet network for humanoid teleoperation. There has been a strong demand for teleoperation technology for unstructured environment such as nuclear facilities, toxic waste cleanup, and explosive ordnance disposal. Especially for disarming explosives, careful and precise teleoperation technology is required. For these reasons, efficiency of teleoperation to perform complicated and detailed tasks is very important. For better teleoperation experience, several aspects should be considered. Recent studies on teleoperation have focused on transparency enhancement and motion tracking strategy. However, visual feedback is rarely considered in teleoperation systems. Some studies just apply simple method using monitors to provide monovision feedback. To improve the efficiency of such teleoperation, visual feedback is one of the most important things. While constructing the vision system, immersive experience for the operator was the main focus. The equipment selection is as follows. For the telerobot's eye, which provides images from a remote environment, we chose two Sony action cameras for stereoscopic view. For video transfer process, product called BirdDog Flex 4K In sends videos by NDI IP protocol to the teleoperator. For post-processing at operator site, software Unity 3D was used, which is widely used in developing VR interfaces. For teleoperators' immersive experience, product HTC Vive Pro 2 was used, which is VR head-mounted display device. I will explain why these are selected as our vision system in the next following slides. For immersive experience, we focused on three major problems. By using VR head-mounted display device, stereoscopic view and curved plane rendering provides immersive experience. Also, low latency on visual feedback was conducted. Finally, reducing VR sickness was considered. Stereoscopic view offers depth to the operator, which is one of the most important things in teleoperation. Two cameras mounted on the telerobot provides different images since they are installed with a distance between the eyes. Each camera image will be shown to the operator's left and right eyes. By this choice, the operator can feel the depth in virtual reality space. Sony action camera sends out video output without calibration. For the presented system, rendering the video on a curved plane was used as a calibration process. Rendering to curved plane reduces the effort to calibrate the stereoscopic view. This figure shows the effect of calibration on the curved plane. To see the clear effect, a checkerboard was used. Without calibration, the flat plane has a distorted view. The lines of the boxes are not straight due to the lens distortion. By the way, right image shows relatively straight lines and squares from the checkerboard. For real-time operation, low latency in the video transferring process should be considered. For the video transfer process, Network Device Interface, so-called NDI, is used, which is one of the IP video protocols developed by NewTek. There are several options for IP video protocols, such as Real-Time Messaging Protocol, RTMP, Secure Reliable Transport, SRT, and NDI. The major advantage of NDI is low latency. Its latency ranges from 54 to 75 milliseconds, which is lower than the SRT and RTMP. By using the BirdDog converter device which supports NDI, video by HDMI is transferred with NDI protocol to operator sites. Though there were approaches to reduce latency between telerobot and operator, the latency that the operator can feel still exists because of the internet connection latency or scene rendering latency. These latencies affect virtual reality syncness to the operator. In the real world, when humans move their heads from left to right, the scene in which the human view moves in the same direction in real time. In VR, however, latency exists in the motion tracking process. This leads to VR syncness. Screen fixed with VR world can solve the syncness from motion tracking process since the screen doesn't move. However, this might reduce immersive experience and also might give the operator a limited view when the operator turns their head too much. For this problem, mixed approach was used on our system. While small move, the screen doesn't track the operator's coordinates. Then, if the rotation angle of the operator's head is more than a certain number of degrees, the orientation of the rendered scene is updated to that the operator heads. To check the entire system's visual feedback latency, display-to-display latency was measured. From the Telerobot system, cameras view the frame counter screen, which counter shows 60 frames per second. From the operator side, head-mounted display also gets the frame counter screen. Then the frame difference is measured for latency check. For camera comparison, 30-60 degree camera Ricoh Theta Z1 was used. For IP video protocol comparison, SRT was used. Results are as follows. Virtual reality with stereoscopic view and curved plane rendering reduced distorted view and increased depth for operator. For a lower latency approach, the average frame difference for the NDI protocol was 5 frames, which is 83.33 milliseconds. SRT, on the other hand, average frame difference was 28 frames, which is 466.67 milliseconds. This result shows that the NDI is better IP protocol for reducing latency. Then entire system latency was measured using NDI protocol. The average frame counter difference for the Sony action camera was 10 frames, which is 166.67 milliseconds. For Ricoh Theta Z1, average frame difference was 32 frames, which is 533.33 milliseconds. As you can see on the graph, Sony action camera was giving 720p resolution, which is lower resolution than that of the Ricoh Theta Z1. In fact, for Sony action camera in 1080p resolution also gave almost same frame difference with 720p resolution. So this means that latency between different cameras mostly comes from other reasons. The 360-degree camera Ricoh Theta Z1 captures the entire remote environment, so its image data is relatively large. Additionally, the camera itself has the stitching process, which makes raw image data to equirectangular projection image, causing much more latency. So Sony action camera was the better option for our vision system. 720p was enough for the operator to see clear image, and other stable issues from bird dog converter device, we use 720p resolution instead of 1080p for our vision system. Finally, using mixed approach, 10 participants felt less VR sickness compared to existing method. In conclusion, for efficient teleoperation, we focused on real-time visual feedback and immersive experience for our vision system. To achieve real-time visual feedback, NDI protocol was used, and stereoscopic view offered immersive experience. Finally, due to the trade-off between immersive experience and VR sickness, mixed approach was introduced. For our future work, new methods for extremely low latency on visual and extremely immersive experience without VR sickness will be researched. Thank you for listening.